Hey guys, Dr. Brown here, and we're working on a problem that was sent to me by one of the local civil engineering students. Out so that you can see it. So hopefully it won't take me so long to work this. I'll just walk through the steps that I've taken. Let me adjust my camera here. Okay. All right, the problem was the integral of 2 times e to the 4x plus e to the 3x all over the square root of e to the x minus 1, and we're integrating this with respect to x. Now there's two attributes here that you must know in order to work this problem. One, exponential rules. So if you don't know those, go learn them because you're going to need them. The second would be u sub, okay? So how I approached this was, well, I've got a 3x here and the e to the x there. Excuse me. If I were to factor one of the e to the x's out of this, as I've done here, I have 2 times e to the 3x times e to the x. And you know when you multiply exponentials, or a number that has an exponent, it's like a to the m times a to the n. It's a to the m plus n. Same situation here. I have e to the 3x times e to the x. That gives me I factor the e to the 3x out. So now I have it to the outside. I have 2 times this e to the x plus, if I factor e to the 3x out, I have a 1. So now I can distribute this e to the 3x to the inside and get what I had here, multiply that out, and I have the same as to what I started with. It's just in a different form. And all of that is over e to the x minus 1 raised to the 1/2 power because it's the square root. Now then, I chose to let e to the x minus 1 be u. E to the x minus 1, and we know that the derivative of e to the x is e to the x dx. So du is e to the x dx, so I'm isolating the dx because I want to replace it and get everything in the u world. So I divide both sides by e to the x, so du over e to the x equals dx. Now then, if I do that, I still have several of these terms that I can't get rid of if I just plug in everything in the u world. So I thought, well, let me solve for e to the x. Well, u plus 1 is e to the x. So what does that mean in terms of e to the 3x? That's e to the x times e to the x. Remember, we're just adding that exponent, so that would be the same as e to the 3x. So e to the 3x is u plus 1 cubed. Now then, let's take that information and begin plugging in. This e to the 3x here is u plus 1 cubed. Now I have 2 times e to the x, and e to the x is u plus 1. So 2 times u plus 1, that's a parentheses u plus 1. Plus this 1 here. And that's all over u to the 1/2. Recall I let e to the x minus 1 equal u. Now I've got to replace my dx with du over x plus 1, because du over e to the x and e to the x is u plus 1. Hey. Now then, let's reduce. I have u plus 1 cubed over u plus 1. That can give me u plus 1 squared. I can distribute this 2 as 2 times u is 2u, 2 times 1 is 2. All of that still plus the 1 that's here. Over u to the 1/2. Well, if I take this u plus 1 squared, I get u squared plus 2u plus 1. And that's times 2u plus 2 plus 1, which is 3, okay? Okay, it's all over u to the 1/2. Now then, if I multiply this thing out, I end up with this 2u cubed plus 2u squared plus u squared plus, and you can read, so that follows all that out, all over u to the 1/2. So I've got to divide u to the 1/2 by each term, but let me collect the terms first. I only have one cubed term out of all of this. So we're moving up here. That's 2u cubed over u to the 1/2. So 2u squared, 3u squared, 7u squared, 8u squared over u to the 1/2. Let's see, 4u plus 2 is 6u plus 2 is 8u over u to the 1/2 plus 1 over u to the 1/2, and all of that is integrated with respect to u. So looking at this first one, I just reduced it. I have 2u cubed. Cubed is 6 over 2, right? Since I'm getting a common denominator here. So 6 over 2 minus 1 over 2 gives me 5 over 2, 5/2. And I go through that same scenario with each one, and then I integrate 2u to the 5/2 gives me 2u to the 7/2 divided by, or multiplied by 2/7, which gives me 4/7 u, which was e to the x minus 1 to the 7/2. Excuse me. So if we go through that same integration on each one, you end up with this term here. But again, the key to the whole thing was understanding exponential rules and u sub. So I would encourage you, just take your time and walk through this. I've gone through it really fast. But walk through each one, working out the rules of exponentials, put it into a u sub, and just go for it. Why are we doing this? Together we're trying to build a better tomorrow, and do that through math. Keep studying. That's all for now, and we'll talk to you next time. Thanks.